Today we're going to take a look at section 13.4. We're going to be looking at measures of central tendency and variation. Central tendency describes how data bunches up, and variation describes how spread apart it is. Okay? So our leading idea to start with, measures of central tendency and variation help us understand both the typical values in a data set and how much the data spreads or differs from that center. Similarly, faith in God provides a steady center, a grounding purpose, a hope, amid the varied and often unpredictable experiences of life. Just as these measures give us a balanced view of data's consistency and variability, faith helps us find stability and meaning even when life's circumstances fluctuate. Let's pray. Dear Heavenly Father, I thank you so much that you are our consistent place, and that even when things are fluctuating in our lives, that we know that we're grounded in you. I ask that you would be in our class session today, that you would allow the words that I speak and the examples I give to be successful, to be helpful and useful as the students leave and practice these problems later. I also pray that they would ask questions that would help clarify in places that I have not been sufficient. I pray these things in Jesus' name. Amen. So the first part we're going to do today is the central tendency part. So there are 3 measures of central tendency. The first one is called the mean. The mean is also called the arithmetic mean. Sometimes people use the word average for it. It's the average of the values. It's found by adding the values together and dividing by the total number of values. And your grades are an example of this. So we've talked about what happens when we find your overall test average in this class. That's a mean. I add all the tests together, the final counts twice, and then I divide by 6. That is your average test score. Okay? Even the class as a whole has the same process. We would be adding all the points and dividing by the total number of points. It's an average, it's a mean. If I want to look at how a class as a whole did on an assignment, which I typically will do, not in these classes because we grade them a little differently than ours, but if I do this for my contemporary math class or my trig class, I add all the grades together and I divide by the total number of students who took the test. And I can figure out what the average score, the mean score was for that class. This is not the only way to measure central tendency, however. Median is another one. So median is the middle value. It's found by listing all the numbers in numerical order. If there's an odd number of values, it is the value that is smack dab in the middle. But if there's an even number of values, it kind of ends up having 2 values in the middle, and then we average those 2 values together. Add them together, divide by 2. What the median does is it gives us the location where the data sort of splits. Half is higher, half is lower. That's also a useful piece of information. In fact, for grades, when I'm looking at the grades of a class, not at your grades for you individually, but I'm looking at the grades for a class, this is more useful to me, right? It's more useful to me to know that half the class got an 80 or above, half the class got below that, than it is to know that the average, adding them all together and so forth, was an 82. And something's an 82, I don't know if I have a lot of values that are really close to an 82 or if I have values that are really spread apart and how that's affecting things. So we have median. Median is also very helpful when there's something that could skew the data. So imagine you wanted to find, like the average salary for somebody that worked in a company. Okay, seems like a reasonable thing you want to know. But if you throw in the president's salary into that mix, it's going to skew things in a way that's not really accurate for the average people in the company, right? But if I put the median in there instead, he gets his count. I mean, he's on the high end, but he's not skewing the data so that it makes it look like everybody's a little bit higher than they really are. The last one's mode. Mode is the number of values or the number or numbers that occur most frequently. So it can be more than one. If you have 2 modes, it's called bimodal. 3 modes would be trimodal, okay? If every value occurs the exact same number of times, then there's no mode. That's the only time there's no mode, is if everything's occurring exactly the same number of times. Mode is something that people usually use when they're looking at purchasing things. For example, I'm about to go run concessions tonight at a concession stand, okay? And if they know that the blue Gatorades sell so much more frequently than all the other Gatorades, that's far more important than knowing that on average, such and such happens. I just know I need to buy a whole bunch more blue Gatorades, right? Same thing happens for sizes of clothing. If a clothing store is trying to figure out what sizes of clothing to order, they may not need to order equal amounts of clothing from size 0 to size 16, right? They're probably going to order more of the clothing in the middle, right? Not because it's an average number of values, but because that's where most people's sizing gets purchased. So the total number of purchases might tell them that this is what they need to purchase instead, okay? So we're going to take a general data set. It's got no context whatsoever. Most of our data sets will, because I just want us to practice the numerical computations of finding the mean, the median, and the mode. So we have 18, 22, 22, 17, 30, 18, and 12. And as we're finding these, I'm going to put them sort of in the order we had before. Whoops, mean is what I meant to write down. So when we're looking for mean, you've got to show me something. I know you can probably put this all in your calculator and give me an answer, but if you make a mistake, then we're all up a creek and I can't give you any credit. So as sort of a backlash to that, I have to see some work. So you're welcome to do one of 2 things. You're welcome to either write out all the values, 18, 22, 22, 17, 30, 18, 12, and divide by, how many do I have, 7? 7? So you're welcome to write down this step. That's one option. And then give me an answer. Or you're welcome to write down my next step. So somebody just add the top for me. Not do the division, just add the numbers on top. I do not have this number written down, so I really do need somebody to add the numbers together.
139.
Is it 139? Do I have a second? Yes, excellent. We'll go with 139. So if you don't want to write down the original thing I wrote, and you just want to write down 139 over 7, I'm okay with that too. But one of those 2 things need to be on there so that if you write down 138, I can be like, oh, they made a slight error or whatever, and I can give them some partial credit because they knew they were at least supposed to add these numbers together and get to there, right? Like they knew what they were doing, they just made an error in calculation. And the approximate value, we're going to do this with 1 decimal. What is this if I divide by 9, or divide by 7? 19 point, is it 9? 9, fantastic. Okay, pretty good so far. Median, that's my next one. Median means I have to put them in order. Technically, you could go largest to smallest, but more naturally, probably is smallest to largest, so that's what I'm going to do. So what's my smallest value? 12. And then? 17. 2 18s. And then? And then 30. Okay? So we've got them in some kind of a numerical ordering, smallest to largest or largest to smallest. And we want to look for the one that's in the middle. There are 7 values. There's an odd number of them, so there really is one in the middle. What number is it? 18, specifically the second 18, right? It's this one. So my median is 18. So it tells me that half the values are 18 or above, half the values are 18 or below. 18 sort of gets thrown in the middle of it being sort of a little awkward because it is the middle value. Now, let's just do an aside for a moment, and I'll change my color to make sure that you understand that if this was a different problem, I want to make sure you know what to do. I'm going to use the same values that we have on the screen, but I'm going to add one to the end. Okay, just one more value on the end. It makes it even. That's what I'm trying to do. So if I were to sort of count from the edges in to the middle, I end up with 2 values in the middle here. What values are they? 18 and 22. I'd have 2 of them. And if I had 18 and 22 in the middle, I'd need to find the average between them. So I can add 18 and 22 together, divide by 2, and what would I get? 20. Okay? Does that make sense? So there's a nuance, there's a difference when there's an even number of values. Now let's go back to the regularly scheduled programming and we will look at the mode. Okay, so mode just means the number or numbers that occur most frequently. What value or values is that for this data set? 18 and 22. Okay, everybody good? Okay, these are pretty straightforward calculations. We need that mean though, because we're going to use it for something, and we need that median. Those values we're going to use in some further calculations later on down the road. So it's important that we know how to do them. All right, so let's see some applications of how we can actually use means as well, not just in a find the mean, but I can actually do something else with them. So this is the mean score on a test of 20 tests is a 75. What is the sum of the 20 test scores? Now, this is sort of a variation of the same question that sometimes the students will want to know, and this is, and Canvas will do this for you. It has this what if. Are you guys familiar with the Canvas what if? Okay. It's basically telling you what happens or what you would need to get a certain grade, like in the class, raise your percentage to a certain grade, right? So I can use this kind of calculation to do that. Let me show you what I mean. So it says the mean score is actually 20. So my mean is found, I'm going to write it down sort of in words. Mean is the total divided by the number of values. Okay. Would you agree that in words, that's what we're doing when we find mean? Okay. Now, instead of giving us the total, like the sum, and the number of values on this one, that's not what they give us. They give us the mean, which is 75. So I have a 75 over here. And they give us the number of values, which is 20. And instead, they want us to find the total or the sum that goes on top. So I can then multiply by 20. And my sum will be what? It's 1,500. So let me kind of give some context to something here so you could see how I could use this in that what if kind of scenario. Let's say that you're working in a class and it has, instead of 20 tests for like a class, this is what this is describing, there are 20 of your individual homework scores. You could have 20 homework scores in a class, it's possible. It's a lot, but it's possible, right? Okay, and so you actually know what your test or your homework average is. And you want to know what's going to happen, like what can I do to make that 75 a 76 instead? Like what do I need to do to change this puppy, right? Or likewise, maybe I have 20 quizzes when it's done and I'm not quite all the way there. That's a better scenario with my numbers. So let's say I've got 5 quizzes left. Well, if I need a 75 average and I've got 20 quizzes, I need eventually to have 1,500 points. And I could look at all the quizzes that are left and I could figure out how many more points do I need on these 5 more quizzes in order to get to that 75. And that's essentially what happens with your test average in this class too. How many points do I need more on test 2 and test 3 and test 4, to make sure that on the final I'm not feeling super stressed. I have to get, an 86 on the final and I haven't got anything like that so far. It's just stressful, right? So I can look at those kind of calculations. Here's another one. It doesn't fit very well for this particular group of students, perhaps, but that's okay. We're going to do it anyway. If the mean weight of the 7 linesmen on a team is 230 pounds, and the mean weight of the 4 backfield members is 190 pounds, what is the mean weight of the 11-person team? So this is what sport? Football. Okay, good. So the different places on a football team, they're usually different weights of characters, right? These gentlemen are not the same if they're the punter as if they are the quarterback, as if they are a linesman. Like they hold different weights. And so they're showing you by their calculations that it's different. So the 7 linesmen are 230, but the 4 in the backfield are 190, okay? So we're going to figure out what the calculation would be for those particular individuals. Well, the mean is still calculated the same way. The mean should be the sum, in this case, of their weights or their total weights divided by their number of people. Okay, so this is a little more descriptive, pertains specifically to this problem. That's fine. You know the number of people on the team. What did it tell you it was? 11. There's 11 on the team, at least that they're discussing at the moment. It says that 7 of them have an average weight. Their mean weight is 230. So if 7 of them on average weigh 230, what could you do to find their total weight? Yeah, we could multiply them. There's 7 gentlemen. None of them necessarily have to weigh exactly 230, but their average is 230. So if I take 7 times 230, that's the total weight. So imagine, Biggest Loser used to do this. They'd take all the people from one team and they'd set them on a scale. Can you picture that? Right? That's what we're doing. We're taking all the linesmen and we're setting them all on a scale and we're figuring out their total weight, but we're just doing it with numbers. And we can do the same thing with our 4 backfield. We have 4 of them and they have an average weight of 190. Now, our answer better be between 190 and 230. Does everybody agree with that? Okay. And it also better be closer to the 230 than the 190. Why? Because there's more of them. Okay, so the reason I mention these things is because I want you to make sure that when you get to the end and the answer says something, you're like, oh, yeah, that's reasonable. Or, oh no, I definitely made a problem. My daughter did something on a word problem last night. She got negative 56 numbers of couples tickets sold to a homecoming dance. And I stopped her and I said, can we have negative 56 couples going to the homecoming dance? And she's like, oh, no. Right, this matters. She missed a sign somewhere. It's not a big deal, but we were able to fix it. Okay, so multiply this out, add them together, and let's divide by our 11 gentlemen on the team. We'll go with 1 decimal. Most of the things with 1 decimal are good enough. If they tell you to do something different, definitely follow the directions on that. 215.5. And this has got units, so it's 215.5 pounds, right? Okay, so is it between 190 and 230? Yes. Is it closer to 230 than 190? Yes. So at the very least, that tells us that we have a reasonable answer. Okay? It still could be wrong. We still could have made an error. But we didn't do something glaringly wrong enough that we should probably be concerned at this point. Cool? Okay. So this is the grand total of the discussion about central tendency. That was it. Everything else in this section, which is the majority of it, is about variation. Right? So let's take a look at a little bit at the beginning here about variation before we pause to do some group work. Okay, so one bit of variation discussion is range. Range, in this context, is the difference between the greatest and the least value in the data set. Biggest one minus smallest one. And that's telling us the spread. How far apart are those values? And then we can break that data up into quartiles. Quartiles has that word like quarter, right? That same prefix. So it's fourths of something. So the first or the lower quartile, Q1, is the value below which 1/4 or 25% of the data lie. The middle quartile, or Q2, is the value below which 1/2 of the data lie. We've already found this. This is the same as the median, right? 50% mark. That's what the median is, so just another name for it. The upper quartile is the value below which 3/4 or 75% of the data lie. You can also describe it as being the value above which 25 are, right? So 75 or below, 25 or above. Sometimes it makes it more sense to talk about being, the lowest, the top 25% of something, but it's the same thing. Okay, does everybody have those ones written in? Almost? Okay. Okay. A few more pieces. The inner quartile range is the area between the first quartile and the third quartile. In other words, it's the middle 50%. Okay, it's the middle part of the data set. And then we have these values called extreme. Extreme means far, right? That's what it means. It's far in some kind of context. For what we're looking at, it's the farthest data values that are out. So the biggest one is the highest, or the upper extreme, and the smallest one is our lower extreme. And then if we use all this data, we can actually create a box plot, which is another type of graph that displays our data. So we're going to use that same data set that we did before, okay? And we're going to create a box plot so you can see how it all sort of pieces together. And that'll be the last part for what we're doing today before we do group work, okay? Okay, so we have this data set The most helpful way for the data set to show up for the purposes of what we're doing is going to be in order from least to greatest. And we did that before, so I'm just going to write that in here again. We had 12, 17, 18, 18, 22, 22, and 30. And we identified that the mean was the second 18, and now we're going to call that Q2. We've already done that part. Now, if Q2, as we found it, is actually a value that's there, then we are not going to use it as we look at the values before and the values after. If we had done this data set that I sort of did this aside on right here, where we looked at the value and we got the number 20, and the 20 is sort of in between these, right? Then we would still use the 18 and below, and we would still use the 22 and above. Okay, so if we've got an even number of values, we don't leave anything out of our looking at the values that are left. But when we have an odd number of values, which we do on ours, we're going to ignore that value now. Okay? So now we're only going to consider the values that are before Q2, and we want to identify what's the middle value there. 17. That's Q1. And do the same thing on the upper end. What's the middle value on the upper end? 22. This is Q3. And then the first value is our lower extreme, and the last value is our upper extreme. Okay? When the data sets are small, these things actually come through pretty quickly. You don't have to work a lot at them. Most of our data sets are not going to be insane, so this is going to look a lot like what we're looking at. So to draw a box plot, you're first going to draw a number line. This is just to give us a reference. We're not actually drawing on the number line. It's going to lay sort of below our graph. And it needs to have represented all the values that we listed above with spacing that makes sense, right? So I can't just put 12, 17, 18, 22, and 30 on there equally spaced apart. They're not equally spaced apart. Are y'all with me? So I'm going to put a 12 here as my first value, and I'm going to do 13, 14, 15. You may not need to label every single one, but they should all be about equally spaced. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and here's 30. Let me extend my line. And so I've got the 30 there. Okay, is everybody good so far? Okay, the 5 values that I identified, I'm going to put a dot above them on this graph. I identified 12. I identified 17. I identified 18. I found the 22 in that list and the 30. So there's a dot. They're not on the line. They're above the line, but at that value. Okay? On the outside, you're going to connect the dots like this. They should be straight. They're not going to be perfect, but they're close. In the middle, what you're going to do is you're going to draw a box. So the box has actually got a vertical piece here, here, and here. And then we draw them connected like this across. Okay, so mine's not a perfect box with the tools I'm using, but that's okay. It's giving you the right idea. Okay? Sometimes this is not called a box plot because it's called a box and whisker plot. Can you see the whiskers? Like a cat or something, yeah? Okay. So what does this do? Well, it should have a title. Ours doesn't have any context, so I can't really write a title in, but I'm just going to write title on here to remind you that it needs one if there's context. But what is this actually showing you? Well, it's showing you the different quartiles. This line on the outside is the first quartile markings, right? It's the lower extreme to the first quartile. Now, that's not the first quartile, but it is the 25% of the values. The quartile is, Q1 is 17. That's Q1 is 17. It tells you that 25% of the values are below 17, okay? It also tells you that the middle interquartile range is between the Q1 and the Q3. Well, Q3 is over here at 22, okay? 22 being Q3 means that 75% of the values are below 22. Or likewise, you can say 25% of the values are above 22. And you can do the same thing with the median, right? 50% are lower than 18, 50% are above 18. Okay? So it groups data together in a way that we can analyze it as a collective amount of data instead of individual units. And we'll stop.